gas. Okay, so calculate. Very good. Heat generated. So just calculate heat generated based on the equation 12.63b, page number 226. Okay. For that, the unknown parameter is Ft there. Sorry, Fn. For that, you can use this particular formula from the equation number 12.56i, page number 225. Just go for that particular equation, page number 225. 225. So here is the equation. Okay. Equation number 12.56i. So here it is. Okay, so it's in terms of Ft here, but you require the Fn value, isn't it? You can pick the, see here it says Ft is equal to Fn times of cos theta cos gamma minus mu times of sin gamma, isn't it? So you require the value of Fn here. So Fn is equals to Ft, this whole divided by this whole thing that you have to take. You can give the reference number as 12.56i. Take that particular equation there. Okay. Substitute all the things. You know the value of Ft, you know the value of theta, you know the value of gamma. Substitute everything and give me the value of Fn. .79 into 10 to the power of 3 divided by cos 14.38 into cos 7.59 close the bracket. So have to even close the bracket here also. So okay, and minus 0.0405 and sine 7.59. Is the value correct? Is the value correct? 41.67 kilonewton, correct. So 41.67 kilonewton. So once you have calculated the value of Fn, go with the calculation of Qg. So just substitute in 41.67. So here you have to substitute in newtons there. Okay. So what is the value of Qg? Okay. And ಇದು ಫ್ಯಾನ್ ಸ್ವಲ್ಪ ಕಮ್ಮಿ ಮಾಡಿ. Okay, is it clear now, sir? Okay. Okay, kilowatts. I will take it in kilowatts, so 8.087 kilowatt. Next, go for heat dissipated calculation. Same old formula. 12.63b, page number 227. So heat dissipated is equals to 1000 into 30 into 1 minus 0.7569. Okay. You can pick it, calculate the heat dissipated there, and give me the value of heat dissipated. .29 kilowatts. Now, what is your inference? Heat generated because of the meshing of worm and a worm wheel, the heat generated value was 8.087 kilowatt, whereas because of the materialistic property, because of the surface nature of the material, 7.29 kilowatt of heat is being dissipated. By this, what can you infer? Dikshit?
Yes, sir.
Q heat generated ಆಗ್ತಾ ಇರೋದು 8.087 kilowatts of heat generate ಆಗ್ತಾ ಇದೆ. But dissipate ಆಗ್ತಾ ಇರೋದು 7.29 kilowatts. So what's your conclusion or what's your inference?
Additional cooling is required, sir.
Additional cooling is required. Just write that particular statement. Since the value of heat dissipated is less than the heat generated, artificial cooling or additional cooling is necessary. And then you can close your problem. Okay. Okay. So we shall go to the next problem. So next problem statement is very, very small. You can look here. The statement is very, very small. Design a worm gear drive for a speed reduction ratio of 25. Pinion rotates at 600 RPM and transmits 35 kilowatt of power. That's all he has given. And trust me, the procedure all will remain same thing. Nothing will change. Again, there are H to I steps from starting from A, B, C, D, E, F, G, H, and I. Same steps will be there. Same problem. Only this much he has given in this particular problem. Design a worm gear drive for a speed reduction ratio of 25. The pinion rotates, so I dash is being given. That is one data which is given, which is 25, the speed reduction ratio. Okay. And the pinion rotates at 600 RPM. That means the value of N1 is specified as 600 RPM. So that your small n, which is 600 divided by 60. So it is 10 RPS there. And power to be transmitted is 35 kilowatts. That's it. So this is the one thing. And wherever is necessary, certain data are not given, isn't it? So wherever is necessary, you have to assume certain values over there. Okay, 99% of the assumptions you already know it by this time. Okay, if there are any extra assumptions are there, we will definitely do it. That is one thing. And this particular problem comes under which category? I cannot say it as a category, but whether the center distance is given in this problem, whether the center distance is given.
No, sir.
So center distance is not given. So first you need to find the center distance, then you have to proceed with the problem sum. Now, how many of you are confident enough? Okay, just try this problem. I'm not telling you that you must get your 100% results, accurate results. I'm not telling that, but I'm confident enough to face or solve this problem. How many of you are in that particular state? You can raise your hands or can just, okay. Only a few. Okay, good. So let us start. So the first major step in this particular problem is, whenever we start a gear problem, what you have to do is, what you have to do? First major step. So since here the material is not given, no, first you have to assume suitable material there. So identifying the weaker part is the first thing. So before identifying the weaker part, you have to assume a material. So I have gone with this particular assumptions. So for uniformity, always worm well should be made up of harder material. So we will always go with the phosphorus bronze. I have even told you in the last class. So when the material is not specified, you must go with a heat-treated steel for the worm, and always go with the phosphorus bronze for the worm wheel. So corresponding values of sigma D1 I have taken from the table, which I've stated yesterday, 220.6 for the worm and 82.4 for the worm wheel. So it is pretty ordinary that the worm gear is a weaker part because it is resulting in a sliding action, tooth breakage, all will happen, which leads to failure because of the overheating and all those stuff. So always worm wheel would be assumed as a weaker part. Okay, so this is all the story you have to write regarding the weaker part selection. What is our first step? Step number A. Now, so this is a preliminary step. I cannot say it as a step since you're not fixing up on anything. You're not calculating anything. So what is our first step, which is step number A? Yes, anyone? So what is the first parameter that you need to find before all the parameters? What is that parameter? Diameter, okay. Diameter, how will you find?
N2.
Okay, N2 you can find, no issue. Calculate the value of N2. So it's just 25. N1 by N2, no? What is the value of N2? It is 10 divided by 25. 0.4 up. 0.4 RPS. Next, what else you have to find after N2? N2 ಆದ್ಮೇಲೆ ಎಂತ ಮಾಡ್ಲಿಕ್ಕಿದೆ?
Diameter. Enter distance.
Diameter calculate ಹೇಗೆ ಮಾಡ್ತಾರೆ?
Enter distance.
Diameter calculate ಮಾಡ್ಲಿಕ್ಕೆ you require the value of A, no? So that's why center distance you have to calculate first. Same old formula you can use there. Okay. To find the center distance. So which is given by equation number 12.68A, page number 228. That particular formula. Use that. Substitute the value of P. Substitute the value of I dash and give me the value of A, which is center distance. Is the value correct? 42, 438.35. That is the value I have got. Okay, so what is that particular value? 4. So 438. Okay.
Sir, B 35.
Ah, oh, in 35 Allah. Correct. 35 ತಾನೇ ವರ್ಕ್? Yes, it is 35. 35 substitute ಮಾಡಿ. ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ. Okay, 370. So we'll take it as 480 mm. 480 mm. So once the center distance is calculated, as Radhik said, calculate the diameters. Okay. So for the D1, you can go with equation number 12.51. This number 223. Substitute the value of A there and give me the value of D1, which is approximated. Okay, 151.34. So we'll round up it to 155. Now substitute 155 in this particular expression to calculate the center distance. So thereby you can get the value of D2. So am I going at a faster pace? Are you solving along with me, everyone? So if you feel that I am at a faster pace than you can stop me anytime. Okay. So the only intention is you have to solve along with me. 805 m. So 805 m. So diameter 0 to bantu. Next, what is our step? Step number C. What is our step number C? Anyone? What you have to calculate after calculating the diameters? You can refer the previous problem also anyhow. Module, go with the module calculation, use the equation number 12.53 there. Famous equation 12.53a, 223. Again there, one by one, multiple parameters you have to calculate. Sigma d, you already noted it down. Next is go for the V calculation. So V is pi d2 small into. Based on V, you have to go for CV. So that is why first calculate V now.
One 1.011.
1.011. So 1.011. Yes. So based on this particular thing, you can take the equation, substitute here, and give it the value of CV 6.1. I told you in the last class, you must be very fast with your calculators. That would save a lot of time in your examination. Okay, 0.8578. So once the CV value is obtained, go for the face width calculation using equation number 12.64. So there you have to substitute the value of center distance to the power of 0.875 divided by 2. The value was 110.93. So I would approximately write it as 115 mm. Okay, 115 mm. Okay. Approximated value. I have directly written it. Okay. Did everyone get the value? This value 110 point something and 93 and am I right? Okay. Okay. Is the value right? If it is right, then we'll move on with the calculation of FT. Okay. We'll move on with the calculation of FT. So FT is given by, I told you, it is 2 times of MTE divided by UT. What is MTE? It is MT into KL, which is load stress factor or a load factor. So K is equals to 1, that is assumed. So that I have written in red color. If it is not given, assume it as 1. It makes our working simpler. So now calculate the value of MT. For that we have a power equation 2 pi N2 into M2. It is nothing but 2 pi NT by 60. The same thing, it is modified. That's it. Okay. From this you can get the value of MT. So how will you get it? It is 35 into 10 to the power of 3 divided by, it is 2 shift pi into 0.4.
13.9.
So 13, this is in Newton meters, guys. So 13.926 into 10 to the power of 3 Newton meters. Now I want it in Newton mm. So I must add one more 10 to the power of 3. So it would be how much? It would be 13.93 into 10 to the power of 6 now. So whatever value you get, this particular value, if you observe here, it is 13,926.0405 Newton meters. So 13.92 into 10 to the power of 3 Newton meters again. Now I want it in Newton mm. So one more 10 to the power of 3 would add up. So it is 13.92 into 10 to the power of 6 Newton mm. Now substitute the value of M2 there and give me the value of 50. 13.93 into 10 to the power of 6. Because in this particular equation, no, you have to substitute in mm. Because since you are substituting the value of D2 in mm. So if you are substituting there in meters, then no issue. Follow common units. That's it.
34.68.
So 34.68 kilonewtons directly.
Yes, sir.
Now, next you have to go with the Levy's form factor. So before getting into Levy's form factor, you have to decide upon the number of threads on the worm. So in order to decide the number of threads on the worm, you may have to refer the table number 12 point, the small table there, 12.24b, page number 244, where you have 3 different tables at a single stretch, small tables. In that, for the value of I dash greater than 20, you always have a singular thread. That means that 1 is equals to 1. Now, since nothing is given in this problem, assume alpha is equals to 14.5. For alpha is equals to 14.5, the Levy's form factor would be 0.1. But your form factor, only form factor, which is capital Y, is pi times the small y. So it is pi times the 0.1. Keep this in mind. Okay. Substituting all the values in the equation number 12.53 to calculate your module. So give me the module. Siddharth Shekhar, good. There are few people who don't even respond, like Abhirami, Akshay Vijayan, Alphas, even Anurag, Anugraha, Arjun, Ashwin have not even seen you. When I call his name, he will leave the meeting. See? All these small tricks you'll play, man. Ishman module 13.55. Now standardize this using table number 12.2 and give me the value 16. So everyone is agreeing upon 16 because standardizing the value, everyone should agree upon the same value. Everyone is satisfied with the value of 16. Responses from everyone because module deciding is very important. Yes, 16. Okay, so once you got the module, go now to calculate the lead angle, which is step number D. So lead angle is given by the expression 12.46 e to 21. Substitute all the equations there. You have tan inverse. Let me try a shift. Tan inverse of 16 divided by 155. That is 5.89. So it is 5.89 degrees. Okay. So once you have calculated the lead angle, next you go with the dynamic tooth load using expression 12.54. Okay. So substitute all the values. You know all the values there. Nothing is to be calculated freshly. So just do it. 82.4 into 115 into shift pi into 0.1 into 16. So 47.63 kilonewtons it is. So 47.63 kilonewtons. Just check. Keep checking my values. If it is wrong, please let me know. Okay. Now calculate your wear load. In order to calculate the wear load, you have this expression 12.62 D2BK. In that D2BK, you know the value of D2, you know the value of B, you don't know the value of K, that you can get it from the table. 12.30 for the lead angle from 0 to 10 degree. That is the range which is given, and the material what we have assumed, and the hardened steel and phosphorus bronze combination. We can pick the value of wear factor, which is K, from that particular table. Okay, for 0 to 10 degrees of lead angle. Lead angle is 5.89. No? So if you pick it, it would be 0.539. Just check this value. Is the value of this one factor I have picked up from the table? Is it right? Is it right? Is this value right? Just check with the table now.
Yes.
Which table it is? Okay, so it is the value. So just calculate it up. So it is 805 cross 115 cross 0.549. So 50.82 is the value. Okay, 50.82. I guess all the values are correct. So what inference can you draw? If dynamic load is 47, but the wear load is 58, sorry, 50.8. What is the inference or conclusion should I write? Material is not safer. Nitesh? How many of you say material is not safe for the wear? How many of you say the material is not safe for the wear? The dynamic load is 47 and the wear load is 50.82. So that is why you get confused every time. So always I say the dynamic load should be a lower value. Dynamic load should be a lower value. It might be your endurance load, it might be a fatigue load. We used to calculate even the heat load also. The heat load is not there in your syllabus nowadays. It has been removed. So whatever load you calculate, in the industry they will calculate another two types of loads. Okay, which is known as a keynote load and the other is known as an element load. So whatever load you calculate on while you are designing something here in your industry also, so another two loads should come there. There is not there in the syllabus, but whenever you meet a design sector or a steel industry, so while we encounter such design procedures to be designed by you, you will encounter that. Okay, so there another few loads should come. So remember, whatever might be the load, which has to be a lower value? Which one has to be a lower value? Out of all other loads? The dynamic load should be of a lower value. Keep this in mind. Whenever you get confused, it seems it's pretty normal that when you look at the load factors, no, 50.82 and dynamic load is 47, wear load is higher, and you feel it is not safe. That is not true. So always you just think in your mind what sir said. Like for example, what dynamic load should be of a lower value. Whenever you get a conclusion, please remember this particular sentence. The dynamic load should be of lowest of all the values. Okay, that's great. So write the same thing. Since FW is greater than FS, the material is safe against the wear. Just write that sentence. So once we have decided upon the loading calculations is being done, so what next we have to do? What is the next procedure that we need to follow? What is the next procedure? So wear load is done, dynamic load is done. We have compared this thing and gave a result that it is safe against the wear. Yes, very
Efficiency.
good. With the efficiency calculation, same formulas again, same formulas. Pick those formulas. First calculate theta, then calculate mu. Mu, remember, it depends upon the rubbing velocity. You need to pick a formula based on the V, what you have calculated. That's it. That is a procedure what you follow for the mu. For theta, you have a formula directly given in your data handbook, which says it is tan inverse of tan alpha and cos gamma, which is the lead angle. Substitute the values and give me the value of theta here. Later on, we can go with the calculations of mu, coefficient of friction. Okay, today I will be sharing the worm gear notes with you. Okay, this is only for the worm gear. So model 3, still you have bevel gears. Now, first you calculate it. Later we shall have a discussion about this. Okay, I will give you two options. You need to select one. Yes, let us complete the problem very fast because again it is the same thing, guys. It is no change with the last three problems what I have observed for the worm gear. Even I have referred few question papers also. There is no change in the worm gear. All same thing. What is the value of theta? Shift was 14.4. Okay. So theta is 14.4. Next, go with the calculations of mu. You know very well that mu depends on the rubbing velocity. Rubbing velocity is given by pi d1 n1 1000 of cos lead angle. So just substitute it. You get the value of VR there. Rubbing velocity. Even calculate the value of V. Why you require V in the sense you have already calculated it. Just recall the value of V. Through that only you will pick the expression to calculate mu. So in order to pick the right expression to calculate mu, you require V. VR is required to substitute the value there. So VR how much? Shift pi into 155 into 10 divided by 1000 into cos of 5.89. So 4.89 is my value. So 4.89 and 4.87. Pretty much the rubbing velocity and the linear velocity are same. Okay. So for V greater than 2.8, since it is 4.8, no. So V greater than 2.8, you have the formula 0.025 plus 3.281 VR divided by 1000 from the equation 12.6p, page number 226. Substitute the value of VR 4.89 and give me the value of mu. Okay, 0.041. 0.041. Now, since mu and theta both are calculated, substitute in that equation to calculate your efficiency. Let us know how much efficient your worm gear is. How much efficient? What is the value of efficiency? 70.5. It is 0.705. It is 70.5. Now, once the efficiency is calculated, what is our last step in the worm gear design? What we need to check for at the last? Efficiency 70% efficient. You have given a good value, 70% efficient. Very good. What is the last step that you need to take care of? What is the last step that you need to solve for? Heat generated and heat dissipated. Okay. So heat generated, same old formula again. Pick those equations which are solved for the previous problem. So Fn is given by Ft times of cos gamma into cos alpha. So there. So this either you can take this particular expression, which is mu times of sine gamma, or you can leave it. It doesn't make a huge difference. Okay, or else you can take this particular expression directly. Okay. Either you can use this particular formula, which I have given here, this one, or you can use this one. So let us have a check. Someone, if you just please try calculating the value of Fn based on this particular expression. And someone of you just try to calculate the expression which I have taken from the textbook. So this particular expression I have taken from the textbook, and this is from the data handbook. Let us compare the values. That is my intention. Okay. Calculate the value of Fn. Yes. What is the value of Fn? I would calculate from the formula given in the textbook, but you just calculate using the formula given in Siddharth. So what is that value? What is that value?
Fn value, sir.
Okay, so this is the value 35.9. Okay, now just a minute. So now from equation 12.56i, page number 225, what is the value of Fn? Okay, so both are almost similar, I guess, right? I think there is no huge difference. 938, and this is 36.15. What is 36.15? Let me clarify, Mithun. What is the 36.15? What is the 36.08? Which value is that? How did you get it? From the data handbook equation. So there is no major difference. It's up to you. Either you can use the equation which I have given, picked up from the textbook, or else I was searching the equation in the previous class, to where there would be definitely there would be a formula given in the data handbook which I was very much sure of. So I was just checking for the equation of Fn there. So I found this particular equation there. Okay, so where it says Ft and Fn, so both are getting the same values. You can use this particular expression if you do not remember the formula which is given here. Okay, is that clear? Okay. Now, once you have calculated the value of Fn there, just calculate the value of Qg. So I would take this particular value. I would take 36 rather. That would be a better thing. So what is the value of heat generated? Okay, 7.3 kilowatt. So I would take it as 7.3 kilowatt. 7.3 kilowatt. Now immediately go for the calculations of heat dissipated, which is given by the same expression, 12.63b, page number 227. Substitute all the values and given the value of heat dissipated. Simple 1000 into 35 into 1 minus of 0.075, 10.31 or 32. So 10.32 kilowatts of heat is being dissipated. That material has a capacity to dissipate 10.32 kilowatts, but your heat generated is only 7.3 kilowatts. So what is the inference? What is the conclusion that you can give from these values obtained? What is the conclusion? Muhammad Gauss? Cooling not required. Muhammad Gauss. Vikit Hegde.
Yes, sir.
So what is the inference that you can draw?
Cooling agent is
Cooling
not required.
not required because heat dissipated is more. That's good. Now write the sentence: since QD is greater than QG, so heat dissipated is more than heat generated. So artificial cooling is not necessary. Just write the thing there and end your problem. Okay, so there we have solved enough problems on worm gas. So now there is a discussion. All of you just listen here. So until today's class, there will be there for the internals. So internal portions is covered by today's class. So from the next class, we have a dilemma of two different aspects to be done. Number one, solving for the Bevel's gear, because already 3 gears we have covered. Okay, and the Bevel gear is the 4th gear. Solving for the Bevel gear is the first option. Second option, so since we have already covered 3 gears, okay, so Bevel gear would be an option. Okay, so second option would be of going with the module number 1 and covering belts. So at last, if we find time, we shall come back here and cover the Bevel gears. So this is the option number 2. So you have to choose whether should we go with Bevel gears or should we go with skip the Bevel gears and go with module number 1, which is your option number 2. Okay. So now I request